Thank you so much. So, Bharani, a part of what Sharath has mentioned, my question relates to that, and it is with reference to boosting. So we have, you mentioned about, I think, 5 methods of boosting. And my understanding, or everybody's understanding generally, is that progressively, from the first model to the second, it is better, better, better. So why do we have Adaboost if we can have gradient boosting? Why do we have gradient boosting when we can have extreme gradient boosting? I want you to kind of elaborate on the advantages of the lower order models. I mean, I'm talking about, let us say, Adaboost has these advantages which others don't. Something like that you could throw light on.
Sure, Nitin, absolutely. See, it's something like after first standard, you go to second, after second, you go to third standard, right? So you progress. And same is the case with boosting algorithms also. The world started off with Adaboost way back in 1994, if I'm not mistaken. After that, there have been enhancements which people have done. But Adaboost was working on the concept of decision stump. What do you mean by decision stump? You just split the tree once. That's it. Okay, this is called as decision stump. And multiple such algorithms were built, right? And gradient boosting was an enhancement over Adaboost, wherein gradient boosting looks at the errors and it will consider the errors or residual values as the output variable. And then it will start building the model. That's how gradient boosting works. And while bagging and random forest have parallel processing capabilities, that means if you have quad core, and if you're saying that, number of estimators, that is number of algorithms that you want to run 100, for instance. So what will happen is you'll have core 1, core 2, core 1, core 2, core 3, and core 4. And in each of these in parallel, there'll be 4 estimators or 4 algorithms which are going to run in parallel. Such provision is available in bagging and random forest. However, within boosting, since the next algorithm that you build is dependent on the previous one, we cannot perform parallel processing when it comes to Adaboost and gradient boosting. That is when people have explored further, and then today as we stand, we have an amazing algorithm called extreme gradient boosting. Majority of the competitions which are won are won because people started using XGBoost or the deep learning neural network algorithm. So that's how the world has progressed. And then here, yes, we can certainly perform parallel processing by making use of the hardware, by making use of your hard disk also, by making use of your RAM, by making use of your cache memory, etc. People can achieve parallel processing. So that's how the world has progressed. And then extreme gradient boosting is very intense in the sense it takes a lot of time. So people thought, let's make it lightweight. Let us ensure that the processing happens faster, etc. That gave rise to LightGBM and CatBoost. If I'm not mistaken, LightGBM is from Microsoft and this is from Yandex. These two are 2 different companies which have come up with these set of algorithms. Yeah, over to you, Nitin.
Yeah. Thank you, Bharani, for that detailed explanation. So my next question again to you, Bharani, is with reference to the the non-generative models. Now, I'm going to ask you a question in relation to deep learning. So when we discuss about deep learning and then when we come up with a series or the multiple layers, we have the internet to help us. So suppose we are working with, let us say, an image processing application. So we have a standard thing. If for this particular size, use these layers and then you're good to go. You don't really need to reinvent the wheel as far as creating that stack is concerned. So on similar lines, is there any, yeah, absolutely. I didn't want to use that word.
Yeah.
Yeah.
So
So on similar lines, for stacking, you've worked with many projects. So on similar lines for stacking, do you feel that there is a standard stack that you use, a logistic regression and this generally gives a very good accuracy, or it is always we have to reinvent the wheel?
okay. Not about reinventing the wheel, Nathan. Here we do not have any pre-trained models or transfer learning models. Pre-trained or transfer learning models are more towards deep learning.
So
However, here,
my
yeah,
question was basically choice of models. Do
yeah,
we have a standard set of these 5 or these 3 are always better than anybody else? In that perspective, I was asking, not in
sure,
the perspective, yeah.
absolutely. So when it comes to stacking, it is always advisable to use algorithms which have the capability of capturing linear patterns as well as non-linear patterns. Because what if your underlying data follows a pattern like this? Then it has the linear pattern, and also here it has a non-linear pattern. Given this is one thumb rule which people have to follow. And the second thumb rule is, if you are, say, choosing 6 different algorithms, we have to try and use all the algorithms, 6 algorithms, which have different underlying math operations. Ultimately, any machine learning algorithm works on math, some kind of a math. So we have to decide upon algorithms which have very different underlying, math equations, so that each algorithm captures patterns in a different manner. And then when we combine them, it makes a lot of sense. Yeah, that's my take, Nathan.
Okay. All right. Thank you. Thank you. So